We have covered up to 20 questions. Now today we will start with question number 21 of alcohol, phenol, ether NCERT exercise. तो बेटा आपके सामने क्वेश्चन है, आपको बताना है कि reagents का नाम in the following reactions. First is oxidation of a primary alcohol to carboxylic acid. कैसा reagent होना चाहिए बताओ? प्राइमरी अल्कोहल को आपको कार्बोक्सिलिक एसिड में सीधा कन्वर्ट करना है, क्योंकि प्राइमरी अल्कोहल से पहले क्या बनता है? अल्डेहाइड, अल्डेहाइड से कार्बोक्सिलिक एसिड। तो आपको अल्डेहाइड पे स्टॉप नहीं करना है, ऐसा रेजेंट होना चाहिए जो प्राइमरी अल्कोहल को डायरेक्ट कार्बोक्सिलिक एसिड बना दे। स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट, तो ये स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट के नाम बताओ जरा, कोई बोलो स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट के नाम। तो बेटा सबसे स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट है जैसे एसिडिफाइड पोटेशियम डाइक्रोमेट और न्यूट्रल और अल्केलाइन और एसिडिफाइड KMnO4. They are strongest oxidizing agents. So we can use any one of them followed by hydrolysis. किससे? With dilute H2SO4, right? Acid catalyzed hydrolysis. Is it visible? Yes. Okay, we have enough space. Right. So reagents responsible for the oxidation of primary alcohol to carboxylic acid are acidified potassium dichromate or neutral alkaline or acidified KMnO4 followed by hydrolysis. क्योंकि पहले क्या बनता है? कुक COK हो जाता है ना, फिर हाइड्रोलिसिस करेंगे। हाँ, गुड बेटा, वेरी गुड बेटा, शाबाश। ओके, नाउ नेक्स्ट इज के ऑक्सीडेशन ऑफ अ प्राइमरी अल्कोहल टू एन अल्डेहाइड। मतलब आपको रिएक्शन को अल्डेहाइड तक स्टॉप कर देना है। बेस्ट रेजेंट इज, मैंने लिखवाया है आपको, PCC टू convert primary alcohol to aldehyde is PCC, that is pyridinium chlorochromate, that is PCC। इसमें क्या होता है? एक तो pyridine प्लस CrO3 एंड प्लस HCl, इनका 1:1 मिक्सचर होता है ना, और जो बनता है दैट इज C5H5NH पॉजिटिव, CrO3 एंड Cl नेगेटिव। सो ये जो रेजेंट है इसको हम बोलते हैं PCC, इन CH2 Cl2, that is called PCC and is the one of the best reagent to convert primary alcohol into aldehyde। और क्या यूज कर सकते थे? इवन PDC, वो हमने अपने बुक में नहीं लिखा है, बट PDC कैन बी यूज, दैट इज pyridinium, मैंने बताया तो है ही। pyridinium dichromate, C5NH positive twice and Cr2O72 negative, that is pyridinium dichromate, इसको PDC लिखते हैं। सो PCC भी यूज कर सकते हैं, PDC भी यूज कर सकते हैं, है ना, बट जनरली हम PCC ही लिखते हैं। NCERT में PCC दे रखा है ना, इसलिए we stick to that, है ना। Otherwise PDC can also be used to convert primary alcohol to राइट. ओके, नाउ नेक्स्ट वन. ये तो बहुत ही अच्छा क्वेश्चन है. ब्रोमिनेशन ऑफ फिनोल टू 2,4,6 ट्राइब्रोमोफिनोल. इट इज bromine water in aqueous bromine. मैं bromine in CS2 यूज करूं, पोलर मीडियम में यूज करें तो ट्राइब्रोमो बनता है. अगर नॉन पोलर मीडियम CS2 में रखें तो वी गेट मोनोब्रोमो प्रोडक्ट, 2 ब्रोमोफिनोल एंड 4 ब्रोमोफिनोल. एक्वस में फिनोल एग्जिस्ट एज फिनोक्साइड और नॉन पोलर मीडियम में इट एग्जिस्ट एज फिनोल ओनली. ओके, बेंजाइल अल्कोहल टू बेंजोइक एसिड. बेंजाइल अल्कोहल, यू नो बेंजाइल अल्कोहल, और आपको बनाना है बेंजोइक एसिड. सेम वही प्राइमरी अल्कोहल ही है. Again use alkaline, neutral or acidified KMnO4 followed by hydrolysis. Same reason. Neutral or alkaline or acidified KMnO4, the potassium dichromate acidified in followed by hydrolysis. Dehydration of propane 2-ol to propene. Propane 2-ol, देखो ये है propane 2-ol और बनाना क्या है, प्रोपीन. डिहाइड्रेशन हो रही है, रिमूवल ऑफ वाटर. बताओ, कॉन्सेंट्रेटेड H2SO4 अराउंड अबाउट 85% H2SO4. ठीक है. और यू कैन राइट कॉन्सेंट्रेटेड H2SO4 at 443 Kelvin. ओके, लास्ट वन इज ब्यूटेन 2-on. ब्यूटेन 2-on और उससे बनाना है ब्यूटेन 2-ol. ब्यूटेन 2-on to ब्यूटेन 2-ol. You can use catalytic hydrogenation or you can use lithium aluminum hydride, but it is expensive, so we can use sodium borohydride even. All of them can convert ketone into alcohol. Now question number 22. Question number 22 is give reason. Very easy question. You can answer without looking at the question even. If you listen, give reason for the higher boiling point of ethanol in comparison to methoxymethane. Yes, this is ethanol. I think no one can deny of answering it. It is very easy question for you all. All of you can answer it. That ethanol is associated through intermolecular H bonding, which is absent in ethers. That's it. So alcohols have always higher boiling point than ethers of comparable molecular masses. Give the IUPAC name, and these IUPAC names are a cup of tea for you. Give the IUPAC names of the following ethers. First one is C2H5 O CH2 CH CH3 CH3. Second one is CH3O CH2 CH2Cl. Third one is NO2 C6H4 OCH3 para. P for para, okay? Then CH3 CH2 CH2 OCH3. Then fifth one is benzene ring, cyclohexane OCH2 CH3 CH3 CH3. And last one is OC2H5 and CH3. These are the substituents. So OC2H5 should get number 1. So it is 1 ethoxy 2 methyl, because 1 ethoxy and at 2 methyl, these are substituents, and propane. That's it. What about this? Okay, because methoxy ether is taken as a, though it is a prefix, but I think because of its, it can be, I think we can write it as 1 chloro 2 methoxy and ethane. I think better to write it 1 chloro 2 methoxy. Okay, this one, so it can be written as benzene ring NO2 and OCH3. But in this case, this whole thing is called anisole. Benzene along with OCH3, it is called anisole. So we can write it as 4 nitro anisole. 4 nitro anisole. And what about this? Yes, we can write it as 1 methoxypropane. Don't write methoxypropane, because it can be 2 methoxypropane then. Methoxypropane, 1 methoxy or 2 methoxy, but it is 1 methoxypropane. Okay? Yes, what about this? Now, in this case, lowest locant rule is followed. So, it is 4 ethoxy 1,1 dimethyl and cyclohexane. 4 ethoxy, because lowest locant rule is followed. So there are 2 methyl groups, so it will get number 1. Alphabetical order is not applicable here. Why? Because if there is only 1 methyl, then we apply alphabetical order. Okay? When lowest locant rule is failed, then alphabetical order comes. Right? But in this case, there are 2 methyl, 1 ethoxy. So lowest locant rule is followed. Okay? Here simply it is ethoxy. No need to write 1 ethoxy because it is cyclohexane. Now question number 24. write the names of the reagents. Write the names of reagents and equations. Okay, here you can write equations as well. Equations for the preparation of the following ethers by Williamson's synthesis. Okay, Williamson synthesis. So first one is 1 propoxy propane. Second one is ethoxybenzene. Third is 2-methoxypropane. And fourth one is 1-methoxyethane. Yes, 1 propoxy propane. What are the reagents? You know, in Williamson synthesis there is one alkoxide, sodium alkoxide, and other one is alkyl halide. Okay, so we get RO, R, if it is R dash X, RO R dash X plus NaX. That's it. But here it is worth mentioning that alkyl halide should be primary as far as possible. Okay, because if they are secondary or tertiary, then alkene may be the major product. In tertiary, exclusively alkene is formed. If alkyl halide is tertiary, then we get alkene as the major product or sole product. And in case of secondary alkyl halide, we get alkene as well as ether. Okay, there is mixture is formed, right? But if it is primary, then it undergoes SN2 reaction easily and we get the product. So they say if we have 1 propoxy propane, first write the structure. 1 propoxy propane. On both sides there are primary carbons. So no need to worry. 1, and it is symmetrical as well. So we get the reagents. One is sodium propoxide and other one is alkyl normal propyl chloride or any halide. That's it. Okay. Done. And SN2 reaction takes place. Just slightly heat it. Okay. So that is first one. Now ethoxybenzene. Yes. In case of ethoxybenzene, you know, this is ethoxybenzene. So can you guess? Say, one pair is sodium phenoxide plus CH3, CH2, Cl. Other pair is CH3, CH2, ONA. Which pair will give this product? First one or second one? Or both? In second one, CCl bond acquire double bond character and this reaction will not take place. Okay, but in this case it can easily attach here and we get the desired product. Okay, right. And moreover, it is a primary alkyl halide. Okay, very good. Now third one, 2-methyl 2-methoxypropane. 2-methyl 2-methoxypropane, or you can write it like this. Okay, so now again there are two types of possibilities. First is CH3CH3ONA plus CH3Cl, and second one is CH3CH3CH3Cl plus CH3ONA. Yes, again tell me which pair is, because we cannot break either from this side or this side. So tell me which pair is giving the desired product. Because there is sodium tertiary butoxide and ethyl chloride. Again SN2 reaction takes place because it is a primary alkyl halide, but in this case there is a tertiary alkyl halide, so it will react. We get alkene rather than ether. Okay, because it is tertiary alkyl halide, so we get alkene plus sodium chloride and along with ethanol. 5. Illustrate with examples the limitations of Williamson synthesis for the preparation of certain type of ethers. Okay, so we have to write the limitations of Williamson synthesis for the preparation of certain type of ethers. For example, if you would like to prepare this ether, is it possible to prepare by this synthesis, Williamson synthesis? By using that, can you able to prepare it? No, because to prepare it we should have chlorine on one side. There should be a tertiary alkyl halide and that will give alkene. Okay, so it is not prepared by Williamson synthesis. Even if we try to prepare this ether, obviously we need secondary alkyl halide, and in this case again we get ether along with alkene as a major product. Okay, so these cannot be prepared. Even diaryl ethers, is it possible to prepare by this method? No. So these type of ethers cannot be prepared by Williamson synthesis. Okay, because in every case we need, see, aryl halide, there is a double bond character, reaction will not take place with any even phenoxide or alkoxide. Okay, here tertiary alkyl halide, again same case, elimination is the major product. Here secondary alkyl halide, again elimination is the major product, because only alkyl halide should be primary. Alkyl halide, if it is primary, then it will give the product in an appropriate amount which is required by us. Done? I think it is clear to you. Very good. Okay. Even diaryl ethers cannot be prepared by this method. Next, question number 26. How is 1-propoxypropane synthesized from propane 1-ol? Propane 1-ol. What we do? First we take 1 mole of propane 1-ol and convert it into normal propyl chloride. Just use BCl3. Take another propane 1-ol, second molecule of propane 1-ol, and treat it with sodium. We get sodium propoxide along with H2. Okay, then treat them by which method? Which method? Williamson ether synthesis. Okay, and sodium chloride is removed and we get CH3, CH2, CH2O, CH2, CH2, CH3, 1-propoxypropane. Okay, that's it. Okay, then question number 27. So Williamson synthesis can be used, or even we can use another method that you know. Which method? CH3, CH2, CH2OH with H2SO4, not at 443 Kelvin but at 413 Kelvin. So we get ether as the product, okay, along with water. That's it. Okay. So by these two methods we can prepare 1-propoxypropane. Okay, next question number 27. Preparation of ethers by acid dehydration. Is it visible? acid dehydration of secondary and tertiary alcohols is not suitable method give reason. Is not a suitable method. Tell me. Acid catalyzed dehydration we have done for propane one all. So question is preparation of ethers by acid dehydration of secondary and tertiary alcohols is not a suitable method. Why? Very good, very good. What happened? For secondary and tertiary, very good, because of steric hindrance, like if we have simplest secondary alcohol, okay, so acid catalyzed, first of all H plus will attack, we get CH3CH protonated alcohol, and then water is removed and we get CH3CH3 positive. Carbocation is formed, okay, and this carbocation, when this carbocation is attacked by second alcohol, second molecule of same alcohol, reaction is not possible because of steric hindrance. But H plus ion is easily removed and we get propene as the main product. So propene is the product formed actually. Okay, and for tertiary, even worst, because these carbocations are stable. Okay, in case of tertiary, we get tertiary carbocation, which is again stable. So in tertiary carbocation, again reaction with another tertiary butyl alcohol is not possible, but they can easily form isobutylene. These are the simplest secondary and tertiary alcohols. So what about others? So keep in mind, whenever we have secondary or tertiary alcohol and acid dehydration takes place, so we get alkene at the end. Okay, ethers are not formed. That's why it is not a suitable method to prepare ethers. Okay. Right? Very good, beta. Next question. Question number 28. Explain, write the equation for the reaction of, write the equation for the reaction of hydrogen iodide visible? Yes, hydrogen iodide with, first is again 1 propoxy propane, second is methoxybenzene, third is benzyl ethyl ether. Yes, do it fast. फैन तो ऑफ करें. Yes. Yes. हाँ, very good. Next बोलते लिखते जाओ, very good. So देखो, first is CH3, CH2, CH2, O, CH2, CH2, CH3 plus HI to give CH3, CH2, CH2. देखो HI से करेंगे तो we get ido, 1 idopropane and propane volume. Very good. Second one, methoxy benzene. So obviously it cannot break because of double bond character. Only this side will break. So we get phenol along with methyl iodide. Then second one is, last one is benzyl ethyl ether. So benzyl ethyl ether, you know, say in this case SN2 reaction takes place, simple SN2, but there is no need to write SN1 or SN2 because only one product is formed. But in this case especially, what is the product? Tell me. CH2, sorry. Yes, tell me what is the product formed and which mechanism it will use. And what is the temperature? That you know, 373 Kelvin. But in this case, mechanism is, yes, tell me. SN1, because you know benzyl carbocation is most stable along with CH3 CH2 OH. Today see Gunnu is also with me. Today she is also studying with you. Okay, so in this way, why we get benzyl iodide? Because benzyl carbocation is stabilized by resonance. That's why reaction is SN1. Okay? Done? So this is question number 28. अब हर्षिल बेटा बातें करने लगे तो फिर वो बातों की धनी है, फिर बातें करते रहेंगे। कोई नहीं, कोरोना खत्म होता है फिर वी विल गो फॉर अ पिकनिक, देन वी विल मीट ऑल। ठीक है, ओके। नेक्स्ट क्वेश्चन इज एक्सप्लेन द फैक्ट that in aryl alkyl ethers first the alkoxy group activates the benzene ring towards electrophilic substitution and second it directs the incoming substituent, the incoming substituents to ortho and para positions in benzene ring. Very easy question. Same is the case with phenol. If we have alkoxy aryl alkyl ether, then you know this lone pair become pi bond become lone pair. Means OR act as a plus R effect group having plus R effect, and that's why that will increase electron density on the ring. It will increase electron density on the ring, right? Or at the same time it is like this. Means it go on up to this resonance, you know all. See, negative charge, it first of all OR has plus R effect, means plus resonance effect, and that will increase electron density of the ring. So attack of electrophile increases. It enhances the attack of electrophile on the benzene ring. That's why it is an activating group OR, At the same time, it increases electron density, particularly at ortho and para position. That's why it directs electrophile to attack at these positions. 2 ortho and 1 para. That's why this is ortho para directing. Simple. Done? Very good. You know all. Great. Now, question number 30. Write the mechanism of the reaction. Write the mechanism of the reaction of HI with methoxymethane. Write the mechanism of the reaction of HI with methoxymethane. That you know, it is again SN2 type reaction. So carry on in the step 1. What happened? Let us take methoxymethane and HI. So in HI, H got positive, I got negative. So obviously H plus will attack here. So we get protonated ether along with I negative. Okay, and then I negative will attack what is the name of this molecule? Methoxymethane, then it becomes, what is this? Dimethyl oxonium ion. Okay, now on dimethyl oxonium ion, iodide will attack. This is dimethyl oxonium, iodide will attack on it, and you know, this will attack, and as iodide start attaching to CH3, CH3 O bonds start breaking. This is the situation. Okay, and ultimately we get CH3I and CH3OH. But if HI is in excess, then again this methanol will convert into methyl iodide. But if HI is 1 equivalent, then we get methyl iodide plus 1 methanol. Okay, but if step 3, can I write here? If third step comes into picture only if HI is in excess, then CH3OH plus HI, okay, we get protonated alcohol along with iodide. And last step, step 4, CH3OH positive and iodide. So iodide will attack. This is again SN2. We get CH3I and water. Okay, that's it. So these two steps come into picture only when HI is in excess. Okay, done. Any doubt up to this? Today I did ask. Yes, tell me if you have any doubt. Okay, great. Now next is okay. So let it be. We will continue from 31 question tomorrow. Okay? So bye bye. Thank you, Ashish. Thank you. Okay, beta. Bye bye.